All right. Sorry that we have to do these notes online and over the weekend or whenever you're watching this, but because of the snow day and everything else with testing, we have to get through this. And so this is the best way. These notes I'm going to try to make as fast as possible so we're not sitting on your phone too long or doing like that when you're watching this. So I expect you guys like on the notes in your notebook to write down like these questions and write down the answers and all that. On the back side, you don't have to write all these questions out. I'll tell you what's right. So the first thing we're going to do is, this is stuff you should have done in 7th grade, 6th and 7th grade. Okay, the first day is called simplifying radicals. Radicals is just a fancy name for a square root. So you have a square root. So this is like the square root of 32. So how do you simplify or break down a square root? So you say, what does this divide by? Okay, 32 divides by 2. And 32 divided by 2 is 16. Okay, anytime you have a prime number, you are going to circle it. Okay, what's a prime number? It's a number that divides by itself in 1. So 1, 2, 3, 5, 7, 11, 13, so on. All right, so then you're going to break up 16. What does 16 divide by? Okay, you might say 8 and 2 or 4 and 4. Okay, do you have any prime numbers? No, so keep going. 2 and 2, that's prime, that's prime. 4 divides by 2, 4 divided by 2 is 2, and we are done. The next thing you're going to do is you're going to write down all of your circles. So you have 1, 2, 3, 4, 5 twos. 2, 3, 4, 5. Okay, what you're going to do is you're going to make pairs. So circle any pairing you can. A pair is just a group of 2. Okay, so these 2 match. Okay, if they match, you will write whatever the number is on the outside. Okay, like that. Okay, these 2 match and they're a pair. So you're going to make a little 2 on the outside. This guy, he doesn't have a friend, so he is going to stay home. So again, you make pairs of matching numbers. Every time you make a pair, whatever the number is, you make a number on the outside of the square root. Okay, so that's a pair, goes on the outside of the square root. This guy doesn't have a friend, so he's going to stay home. Okay, and lastly, you multiply anybody outside the house. Okay, I call the square root the house. I'll call it that for the rest of the year probably. So 2 times 2 is 4, and this guy is no one to multiply with, and you are done. That is a simplified radical. Okay, let's do 45. What does 45 divide by? Well, anything that ends in 5 or 0 is divisible by 5. That is prime. 45 divided by 5 is 9. 9 divides by 3 and 3. Okay, everything is circled. We can't go any further. So again, you write out everything in a circle. So 3, 3, and 5. I like to go in order from smallest to greatest. So we had 2 3s and 1 5. These guys make a pair. Okay, so they put a 3 outside of the house. This guy doesn't have any friends, so he's staying home. Okay, there's nothing on the outside to multiply. There's nothing on the inside to multiply, so you are done. Okay, 112 divided by 2. Okay, 112 divided by 2 is 56, I believe. Yes, 56. Okay, what is 56 divided by? Okay, you can go up big numbers, small numbers. So let's do 56 as 9. No, sorry, 8. 8 and 7, my bad. 7's prime. Okay, 8 divides by 4 and 2. 2 is prime. 4 is 2 and 2. Okay, so again, you're going to write down anything that's in a circle. So how many 2s do we have? We'll have 1, 2, 3, 4 2s. 1, 2, 3, 4, and then we have 1 7. So these 2 are a pair, so a 2 goes on the outside. These 2 are a pair, so a 2 goes on the outside. 7 does not have a friend, so he has to stay home. Okay, 2 times 2 is 4, square root 7. All right, last one. Okay, this 2, it's already outside the house. So at the end of the problem, we're going to move him back outside. Okay, or like put him like outside the house with whatever pairs there were. Okay, 150, let's do it easy. Let's do 10 and 15. Are either those prime? No, so keep going. 10 is 2 and 5. Okay. 15 is 3 and 5. Okay, and everything's circled, so we're done. So again, this guy is going to move down and go right here. Write down all of our stuff. We have 1, 2, 1, 3, and 2 5s. Okay, so which one makes a pair? Does 2 make a pair? No, so it has to stay home. Does 3 have a friend or a pair? No, so he has to stay home. Does 5 have a match or a pair? Yes, there's a 5 right next door to him. So they are going to create a 5 right there. Okay, so any pairs of 2 gets to go on the outside, but you only move whatever the number is goes on the outside. So 2 times 5 is 10, and then what's inside the house is 2 and 3, so 2 times 3 is 6. And that's the simplified radical. Okay. If you need more help with that, again, you're gonna have a worksheet on it when you get back. I'll give it to you on Tuesday. And then if you need more help, just come see me. So Pythagorean theorem, again, is something that you guys should know by now. When do you use Pythagorean theorem? You only use Pythagorean theorem when you're missing one side of a right triangle, okay? One side. The formula is right here. It's a squared plus b squared equals c squared, okay? Where these are interchangeable. A and b are both legs, okay? So this is the leg, this is a leg. This could be a or b. Same thing here. This could be a or b. Okay, so again, you should be able to draw this all out. And then this is called the hypotenuse. We've already learned about that last semester. And that is always the letter C. All right. There's some little shortcut methods. Instead of using this whole formula, there's a way to make it easier. We're going to explain how to do that. I'm going to separate these. Okay. So let's do, I wish I would have done that actually, over a squared plus b squared equals c squared. Okay, so if I want to get c by itself, okay, what is the only thing on the same side as c? So if you're missing the hypotenuse, like you don't know what the hypotenuse is, how do you get c by itself? Okay, notice it has a square. This will be something we talk about the rest of the semester. The opposite of a square or a 2 exponent is a square root. So to get c by itself, you take the square root and it cancels out that square in this. So if you were missing c, the shortcut method is square root of a squared plus b squared. Okay? What about if you're missing a leg? So let's just practice if you're missing a. How do you get a squared by itself? The first step you would do is subtract b squared minus b squared. So a squared equals c squared minus b squared. Okay? And again, how would you get a by itself? Okay, how do you get rid of a square? The way you get rid of a square is a square root. So you just go like that. It cancels out this 2. It doesn't cancel out these 2. Okay, so a equals the square root of c squared minus b squared. Again, we will use these 2 formulas so much. Like we use it this whole unit, we use it in the quadrilateral unit, we use it all the time. So you need to know, if you're missing the hypotenuse on a right triangle, the formula is square root of a squared plus b squared. If you're missing a leg, it's c squared minus b squared and the square root of that. Notice this one's plus, this one's minus, because on this one, we didn't move anything over. We didn't subtract anything over. But on this one, we subtracted the b over. That's why this is minus. Okay. What about if we want to prove stuff is a right triangle, an acute triangle, or obtuse triangle? Okay, so the formulas are, for a right triangle, a squared plus b squared has to be equal to c squared. Okay. on an acute, a squared plus b squared is greater than c squared, so the smaller sides are bigger. Okay, and on obtuse, we want the hypotenuse to be the largest. So a squared plus b squared is less than c squared. So obtuse, you want the thing that's the biggest, the fastest it can be. You want this to be the biggest it can be. It has to be greater. But if it's tinier, all of a sudden these two, when they're squared, are going to be greater. So tell me, what are the following? All right, so you'll take the two smaller, so 8 squared and 15 squared. Then you'll do 17 squared, okay? So in your calculator, you do 18 squared plus 15 squared, and that is 549, okay? Then you say 17 squared, okay? Oh my gosh, I just realized I did 18, not 8. My bad, hold on. Delete. Sorry, so this is 289. 289, okay? 17 squared was right here, and it is 289. So what are these? Is AB greater, is C greater, or are they the same? Since they are the same, they are equal, then they are a right triangle. Okay? So the next one, okay? So the two smaller numbers go here, and you square them, so 5 and 9, so 5 squared and 9 squared. Then 12 is the largest, it goes on this side. Okay, in my calculator, I do 5 squared plus 9 squared, and that's 106. Okay, 12 squared, 144. So, is the smaller legs greater? Is the hypotenuse greater? Or are they equal? Well, the hypotenuse is greater. And when the hypotenuse is greater, then it is an obtuse triangle. So this is an obtuse triangle. Okay, again, if these two are greater, then it would be an acute. This goes on the back side. All right. Now this side. Okay, now let's talk about Pythagorean theorem. Here we go. Now I'm going to make you use the shortcut methods. So remember, if you're looking for the hypotenuse, it's a squared plus b squared, and the square root of that. If you're looking for a leg, it is the hypotenuse minus the leg you know. Okay, so what do we have here? What are we looking for? A, B, or C? We are looking for the hypotenuse, okay? So we're looking for C. So C is equal to the square root of a squared plus b squared. So C is equal to, well, what's C? C is x, so I'm going to put an x here actually. So x is equal to the square root of 7 squared plus 8 squared. Okay. This is where you guys aren't really going to like me because I'm going to make you can type this in. So 7 squared plus 8 squared, and that's 113, okay? And I actually believe that is a prime number, so we're not going to simplify it. But whatever number you get in here, you're going to have to break it down like we did on the front side, okay? There is a trick. You can go to y equals and do 113 divided by x, okay? And then go second table. And you start at 1, and I would just go to like 20 and see if there's any numbers that divide nicely over to here. And it doesn't look like there is. There's nothing like 4, 5, 6, okay? So I'm going to assume that nothing divides by 113. Okay. So again, that trick was the number divided by x, and then second table. All right, so this one, what are we looking for? We know this is C, so let's make the one we don't know A and this one B. So how do we find A? A is the square root of C squared minus B squared. So A is our unknown. Okay, C is 11 squared. B is 3 squared. And it has to go C and then B because you're subtracting the B. Okay, you're subtracting the leg. You have to put the leg here. It goes hypotenuse and then leg. Or on this one, it's interchangeable because it's a plus sign. This minus sign, you have to put B here or else it will not work out. So let's see what that is. Okay. So what should I make this work? Let me see. Okay. So 11 squared minus 3 squared is 112. So I do think 112 is going to break down. Okay. So let's break this down. Again, if you want to do the trick, you can do 112 divided by x. Okay, so that's 4 and 28. Let's see if we can find something even smaller. What about 8 and 14? That one's nice. Or 7 and 16. Okay, so 7, 16. Okay, 16 breaks down to 4 and 4. Oh, those are not prime. Sorry. 4 and 4, which is 2 and 2. We're going to run out of room. Okay, so here we go. So that's 1, 2, 3, 4 twos. 1, 2, 3, 4, and a 7. Okay, make pairs. So there's a pair of twos. There's a pair of twos. The 7 stays home. Okay, so let's do it up here. So our final answer is a pair of 2, a pair of 2, 7 stays home. So 4 square root 7. There you go. I think we actually did that number on the front side too. All right, maybe I'll write a little tinier this time so we have a little bit more room. Okay. So what are we looking for here? We're looking for C. Okay, so if we're looking for C, we know that C is equal to A and B, the square root of A squared, so 18 squared, plus B, 15 squared. Okay. 18 squared plus 15 squared is 549. Again, it's a large number. So you're going to come here and do 549 divided by x. Okay. Second table. Well, there's a good one. 9 and 61. That's probably the nicest we'll get. Yeah. All right. So we have 9 and 61. 61 is prime. Okay, break it down. 3 and 3. All right. So how do we find C? C is equal to, write them all out. We have 3, 3, and 61. There is a pair of 3s. 61 stays home. So that would just be a pair of 3 makes 3 on the outside. And 61 stays home. And there's your answer. All right, last one. Okay, what are we looking for? This is C. So the other two are A and B. So we know that one, the unknown is A. The one we know is B. So how do we solve for A? A leg is equal to the hypotenuse squared minus the side we know squared. Okay. So 30 squared minus 24 squared equals 324. Okay. Let's get ready to break it down. So come in here, if you have the old school calculators, and do 324 divided by x. Okay, we have 9 and 36. We have 12 and 27, 18 and 18. Whatever one you want to do, you can do. Okay, let's do, I'm going to do 9 and 36 because I like that one. So 36 and 9, this would be 3 and 3. 36 obviously is 6 and 6, which is 3 and 2. 3 and 2. So now let's count everything we have. Okay, we have 1, 2 twos. Okay, we have 2 twos. We have 1, 2, 3, 4 threes. Okay, So the side we don't know right here. Okay, so x equals, we have a pair of 2's. So that means a 2 on the outside. A pair of 3's, put a 3 on the outside. A pair of 3's, put a 3 on the outside. Oh, we have nobody who's staying home. That's okay. So your final answer is, what's 2 times 3 times 3? 2 times 3 is 6, times 3 is 18. So x equals 18. All right, so what is a Pythagorean triple? Pythagorean triple is just 3 whole numbers that satisfy a squared plus b squared equals c squared. So that means when you plug in a squared and b squared, okay, if you took the square root of it, it's going to come out to a whole number. All 3 numbers, like when you plug them in, will be a whole number. Like if you're missing this one, 5 squared minus 4 squared, and the square root of that is 9. The square root of 9 is 3. Okay. 5 squared is 25. 12 squared is 144. That's 169. The square root of 169 is 13. Okay. All these numbers, so like what's saying is a squared plus 15 squared. We take the square root of 289. You should get 17. It's a whole number. So all Pythagorean triples are, when you plug in the 2 legs, the hypotenuse will come out to a whole number. When you plug into a squared plus b squared, c squared will be a whole number. Okay, so this is the 3 most popular. This one is very popular. So what these little dots and everything, every year I try to explain, is you might see a 3, 4, 5, but it might not be a 3, 4, 5. It might be a 9, 12, 15. Okay, what did I do here? All of these were multiplied by 3, but when you divide them by 3, you will get back to a 3, 4, 5 triangle. Okay, so again, you might see in a different version, you might see this one as 25, 60, and then 65, which means each of these numbers was multiplied by 5, but you can break it back. And so if you did 25 squared plus 60 squared, it would equal 65 squared, okay? But again, when you divide these all by 5, you get back down to the basic 5, 12, 13. All right, so an example of this one, you might see an 8, 15, 17. Again, a squared plus b squared would equal 17 squared, wherever that is. So you might see this as, 16, 30, and 34, which would happen to all these. They were all multiplied by 2. So when we divide by 2, it goes back to the 8, 15, 17. Okay. Usually I make my classes do an example. Again, one more, you might see this as a 70, a 240, and a 250. If you took 70 squared and 240 squared and put them together, it would be the same as 250 squared, because when you divide all of these by 10, you get a 7, 24, 25. All right, so what, again, all this is if you take the 2 legs, square them and add them together, the hypotenuse, when you do the square root of it, it will still be a whole number. So all 3 numbers have to be a whole number. All right, last one. Okay. Again, these aren't that long. You could write these out just fine. Okay, so number 1 says find the length of a rectangle. So draw a rectangle. If the diagonal, that's what a diagonal is 25 feet, and the width, length times width, is 15. Well, we don't know the length, right? So if you want to draw it out separately, obviously this is the right triangle. We know the length, or we don't know the length, we know the width, and we know the hypotenuse, okay? So this is B, this is C, so obviously this is A. How do you solve for A? Our length will be the square root. Do you add or subtract these? You should know. Okay, because we have the hypotenuse and a leg, we are going to do the hypotenuse squared minus the leg we know squared. Okay, so 25 squared minus 15 squared is 400. At this point, before you start breaking it down, I would go and check. If I do the square root, which is just this right here, it's the blue button, and then the squared button of 400, see if it comes out to a whole number. Because if it comes out to a whole number, you don't have to do all of this mess. And it did. It came out to a whole number. What's the square root of 400? It was 20. So our length is 20. All right. The next one, a 20-foot ladder leans up against a wall. The base is 8 feet from the wall. Okay. How high is the wall? If you cannot visualize this, draw a triangle. It says how high. How do you measure height? You measure height by going up and down. So which one of these would be the ladder? The one on the floor or the one up here? Hopefully you said the hypotenuse, the diagonal. That's the ladder, and the ladder is 20 feet. See if you need to draw a ladder, you can. Okay, the base is 8 feet from the wall. Base just means the floor. So the ladder is 8 feet on the floor from the ground. Okay, so how high is it? So what do we have? We have C, and we have a leg. The leg we know is always B. So we're solving for A. So how do you solve for A? You take the square, you minus it, or sorry, the hypotenuse, minus it from the leg you know. Okay, 20 squared minus 8 squared is 336. Do the square root of 336. Oop, it's a decimal, so we have to break it down. Okay, 336. Obviously, this divides by 3, I'm sure. It's 112. We already did 112 earlier up here. So that means, let's do 716. Let's do 4, 4, which is 2, 2, and 2, 2. Whew. Okay, write out everything I know. Let's do it over here. Okay, we have 1, 2, 3, 4 twos. 1, 2, 3, 4 twos. We have 1, 3, and we have 1, 7. So this pair of twos goes on the outside. We have a pair of twos, so we put 1, 2 on the outside. 3 has no friends, so he's staying home. 7 has no friends, so he is staying home. So how high is the wall? The wall is 2 times 2 is 4. Square root of 3 times 7 is 21 feet. That's the answer. All right, last one. Here we go. George rides his bike 9 miles south. Okay, what does that mean? South is going down. So he went 9 miles down. And 12 miles east. Never eat. So east is this way. So he went 12 this way. How far is he from his starting point? So he's here. His starting point was here. They want to know what's the shortest path. So here, this is what we're looking for. So this is C. So we are looking for C in this case. We know A. We know B. So how do you solve for C? How do you solve for the hypotenuse? You don't subtract them, you add them. So it'd be 9 squared plus 12 squared. Okay? 9 squared plus 12 squared. And that's 225. Okay? The next thing I would do is I would check to see if I do square root of 225. Does it come out to a whole number? And it does. It comes out to 15. So we are done. So he is 15 miles from his starting point. But again, if it came out to a decimal like this one did, then you're going to have to break it down. And I want you to break down all of them by hand. So, all right, this is about 30 minutes. That's a whole class period. So, again, I will give you the worksheet. If you want to stop by earlier and grab the worksheet, you can. But, yeah, if you have any questions, please come see me. This is a very, very, very important lesson. So, hopefully, you guys don't have too many questions. Have a great day. Bye.